Good morning, ladies and gentlemen. My name is Skalyga Vadim. I am really glad to present here our quite ambitious project. It's still at the R&D stage, but we really hope to finish it there soon. And today I'm going to tell you about compact neutron generator for nuclear medicine. So today we cares only about physics. So we are going to involve medical people at a later stage. And today we see two main applications for neutrons in the nuclear medicine, very interesting for us. First of them is kind of medical diagnostics, which deals with production of molybdenum-99. And the second one is a kind of very effective cancer treatment called boron neutron capture therapy. So in both cases, the problem is the same. It is necessary to replace nuclear reactors in these two technologies, to replace them with another neutron source which will be cheaper and safer. So let's go to the first problem, production of molybdenum-99. It's a very important radioisotope which is used for medical gamma ray diagnostics in all hospitals around the world. And the problem is that molybdenum-99 is produced in big nuclear reactors, and it is necessary to deliver it from the reactor to the hospital very fast in 66 hours. And then at the hospital it is used to produce technetium-99, which is the best radioactive tracer in the world for today. So their market today is huge. It's about 13 billion euros per year. And here's the problem. So there are two ways of production of this isotope. First one uses highly enriched uranium. And uranium is dangerous by itself, and also production wastes are really radioactive. And this method is kind of non-environmental friendly. So another one is to irradiate natural isotope, stable isotope molybdenum-98 with dense flux of neutrons, and to get molybdenum-99 in this reaction. So here, to produce dense neutron flux, nuclear reactors are used now, and our ambitious project is devoted to make a neutron source which can replace this nuclear reactor and move production of molybdenum from nuclear reactors directly to hospitals. So the next problem is boron neutron capture therapy, shortly BNCT. So the idea of this method is the following. The patient takes a special drug which delivers boron directly into the cancer cells, not to the healthy tissue. It accumulates, this special drug accumulates in the ill cells, and after this the patient is irradiated with the neutron flux. Neutrons interact with boron much more efficiently than with other nuclei in the live tissue, and that's why neutrons damage only cancer cells. This method has a very high selectivity, and that's why it is very efficient. So it has been tested at many nuclear laboratories in the world. More than a few thousand of patients tried this kind of therapy, and the results are really good because this method can be really efficient in case of radio-resistant and non-operable tumors. So sometimes it's the only method to help the patient because all other conventional methods of cancer treatment are not efficient. So, but the main problem that all these medical trials were performed at nuclear reactors. It is not possible to put nuclear reactor directly into the hospital, so it's a really exclusive kind of therapy now. There is another kind of product now at the market called proton accelerator, which can replace nuclear reactors, but it's still quite huge and quite expensive. So here's our proposal, a compact neutron generator. It's a tabletop device which can replace nuclear reactors in these two applications. So it's absolutely safe. It can be placed in the hospital without any risk of radiation or explosion and so on. So the price will be about 2 million euros. And if it is a kind of device which can be installed in every hospital, so we estimate the total market is, as this value, about 10 billion euros. So why we are able to have such success? So we recently have developed a unique ion source, high current ion source with gyrotron plasma heating. Gyrotron is a special device, a microwave generator which can produce very high frequency radiation with high power. And due to this, we are able to produce plasma with unique parameters. And we use it for production of ion beams of deuterium ions with record current. And we decided to use these strong beams for production of neutrons. So all this research became possible at the Institute of Applied Physics of Russian Academy of Sciences, because this institute is the inventor of these powerful microwave generators, gyrotrons, and the world leading developer in this field. So at this institute, we had all conditions to start this research and to do the main R&D part. So here I would like to list down the main benefits which can client get when he buy such compact neutron generator. So first of all, it's a room-sized device which can be placed in the regular hospital at room with such dimensions, just 5 to 5 meters. So it can be used for production of molybdenum for diagnostics, and it will reduce the cost of production of this radioisotope really significantly. And at the same time, it can be used for a unique method of cancer treatment called neutron capture therapy. So, and now one advantage is absolutely safe operation, because you don't have any risk of radiation, and explosion danger is so you don't have these problems at all. So it's a kind of solution for regular use in regular hospitals. So our team is based on 2 parts. The first one is R&D team from Institute of Applied Physics, and the business is a responsibility of Commercialization Reactor. Today we have demonstrated the prototype of a neutron compact generator which can work in pulsed mode and show all necessary results. Now we are at the second stage when we are trying to produce the prototype which can work in a continuous mode, and we need some funding to finish this stage. The technology is ready, but they need to buy all the parts. So, and then after this we will go to the market and talk about sales. So our next steps for next year is to found a company in European Union, order the prototype for continuous operation in the Institute of Applied Physics, draw IP rights to our company. So, and for all this they need funding like this, about 1.5 million euros, and time from 1 to 1.5 years. So the result will be a ready prototype for these 2 applications I have described. So thank you for your attention. Questions, please.
Thank you very much.